Hello students, welcome in chapter 11, 3 dimension geometry. It means students 3D. Yes students, today I continue our new chapter, chapter 11 in the 3D. First of all, one of the line related topics, and then after plane. There are two topics, line in a space and second topic, plane in a space. So in this chapter there are the two major parts. So first we going line ahead. So students, in our octane forms, that's your x-axis, y-axis and z-axis, and that's the origin 0 0 0 or 0 vectors. And here students, one line passing through on in this space, just like that. There is a line L having direction L, M, N, and that direction is called L directions. And here students, there is the 2 points, one of the A, one of the general is P. A is considered A directions and B, that point is a R bar, and that to create a two directions wise, O to A and O to P, and these two are the collinear directions. So students, here first of all, vector equation of a line, that is R is equal to A plus lambda L, where lambda belongs to R. L consider directions, A consider passing through line, and students, R is in general. So here I mention R in general XYZ. A is a passing through points x1, y1, z1, and directions LM. And that directions is just like you know that direction cosines, cos alpha, cos beta, cos gamma. So sum of square, cos square alpha, cos square beta, cos square gamma is 1. So here also students, property you can just by heart, L square M square plus N square is equal to 1. And here students, our one of the short introductions for the vector equation of line R bar is equal to A bar plus lambda L. Now students, in continue, R, A and L value I just put it in these equations. So my value is R, A plus lambda L. R is a XYZ, A is your x1, y1, z1, and lambda here L, M, N. Now you just eliminate value of lambda. So students, x, y1, z, and this side x1 plus lambda L, comma, y1 plus lambda M, and z1 plus lambda N. I just compare first to first. So x is equal to x1 plus lambda L. Now here eliminate value of the lambda. So x minus x1 by L. Similarly students, second, y is equal to y1 plus lambda M. Here lambda eliminate. So y minus y1 by M. And third, students, same, z is equal to z1 plus lambda N. Just eliminate lambda. Actually here all lambda I compare and derive one more equation of line. It is called Cartesian equations. Yes. So here z minus z1 by n, and these all three values students I just compare on it. So x minus x1 by L, y minus y1 by M, and z minus z1 by n. That's your Cartesian equation of line. Either symmetric form, yes, it is Cartesian equation of line. Either you can also call it is your symmetric form, where L, M, N is the direction of line, and x1, y1, z1 it is called passing through the line. And students, here L, M, N it means your cos alpha, cos beta, cos gamma, where alpha, beta, gamma is making an angle with the axis for x-axis, y-axis and z-axis. Now students, I will start to easily here example number 1 to 1 by 1 going ahead. So first of all we going the example wise, and then after our exercise. Now students, in example 1, if a line makes an angle 90 degree, 60 degree and 30 degree with the positive direction of x-axis, y-axis and z-axis respectively, find it direction cosines. Students, this is your direction cosines, L, M, N. So here we just taking here L, M, N are direction cosines of given line. And just by taking the angle cos alpha, with the alpha means positive direction with x-axis, it is given that 90 degree. Same M cos beta, here cos 60 degree, and N cos gamma, which is cos 30 degree, and all value you know that cos 90 0, half and root 3 by 2, and that's your direction cosines. Ready? It's your direction cosine. It is 0, half and root 3 by 2. Here easily your first example over. Now we go to example number 2. The same is. Now continue students. In the example 2, if a line has now direction ratios given 2, -1, -2, and determine its direction cosines. Students, very easy. Direction ratios means here L ratio, M ratio, N given. So I just write down L ratio, M ratio, N. It should be 2, -1 and -2. Here ratio. So easily you can cover L, M, N value in the something constant, just like 2k, -1k and -2k, and all sum of squares. You know that students easily it is 1. And that wise I just easily find out my values. L square, M square, N square is equal to 1, and apply the values. L values is a 2k, M -1k, N -2k. So 4k square, 1k square, 4k square, and 4 and 4 8, 8 and 1 9, 9k square is equal to 1. K becomes students 1 by 3, and that put your values in L, M, N. So what's your L is 2k, comma -1k, and third -2k. So your direction cosine is 2 by 3, -1 by 3 and -2 by 3. It's simple and easy way. Students, here example 2 also done. After that example 3 and third also in the same way students I going. Now continue students, example 3rd. Find the direction cosines of the line passing through the 2 points given A and B. Students, here direction cosines to passing through, it means here I take one of the first directions, A to B. A I have -2, 4, -5, and B I have 1, 2, 3. It means I just derive only directions. It means A to B I going that my direction sides. And then after direction cosines are very simple, calculate. So first we will do directions. Direction AB means B positions vector minus A position vector. B I have 1, 2, 3 and A I have -2, 4, -5. So it will create 3, -2 and 3 plus 5, 8. Now you will check magnitude on it. AB magnitudes, it is a 3, -2, 8, and my value is easily here 9, 4 and 64. 64 and 9, 68, 68 and 9, 77. Yes, 68 and 9, 77. So direction cosine, very easy, this number divide on it. So 3 by root 77, comma, -2 by root 77, comma, 8 by root 77. And it's very easy and simple, students. Here this question is done. Now example number 4. Now students, continue in example 4, which is IMP for exam level. Question is, find the direction cosines of x, y and z axis. So respectively, students, you know that is your z axis, here x axis, and that is y. The z, x and y. I want to, if you x axis direction cosines, so surely x axis making an angle with x 0 degree, but with y and z 90 degree. So students, I will take here x axis is making angle 0 degree, 90 degree and 90 degree with x, y and z axis, that you know. So easily you can cover your element. Yes, so direction cosine L, M, N, it become same as, that is cos alpha, cos beta, cos gamma, and apply degree with 0, 90, 90. So here students, cos 0, cos 90 and cos 90. So cos 0 1, but other is 0. That is your direction cosines. Similarly students, your y-axis is making with itself 90 degree with x, y with 0 and z with 90. So similarly, again I direct written direction cosine of y-axis, and same as students, we will write down direction cosine of z-axis. Easily you can write down according to your x-axis 1 0 0, here 0 1 0 and here 0 0 1, and very simple way. Students, this example also our 4 done. Now I continue after that our next example number 5. Now in example 5, students, show that given 3 points are collinear. So direction are same. First I taking one of the direction AB and apply B positions minus A positions vector. B I have 1 minus 2 3 minus 2 3 minus 4. And just subtract it, 1 minus 2 3 and 2 3 minus 4. It will be get minus 1 minus 2 minus 3 minus 5 and 3 and plus 4 7. Next, easily going that direction of second BC now. So BC direction, students, C minus B. I have C ready, 3 8 minus 11, but B 1 minus 2 3. Simple, you derive the two directions here in the way of here 2, next 8 into 10 and minus 11 minus 3 minus 14. Check, they are same. Yes, if you minus 2 common take, then minus 1 minus 5 7. It will be minus 2 times of AB. It means both are in opposite directions with the common point B. So here BC and AB have opposite direction. That's why we will take ABC are collinear. And here students, we simple way apply your, this question is done. Now I going ahead students, our exercise number 11.1, question number 1st. That also same concept, and similarly we going ahead. Now students, in the exercise 11.1, first one, it's same pattern numerical according to our examples. If a line makes an angle 90, 135 and 45 with the x, y and z axis respectively, then asking that direction cosine. So very easy. Here direction cosines are, I just taking L and N. So L, I have known that cos alpha degree having 90 and cos 90 0, sin 90 1 then. Now M and N same as cos beta and here cos gamma. Beta I have known 135 degree and gamma 45 degree. And apply the cos 135. Actually it is indirectly 180 minus 45 degree. So second quadrant minus cos 45. It will be minus 1 by root 2. And here plus 1 by root 2. So your last answer, direction cosine LMN are that 0, minus 1 by root 2 and plus 1 by root 2. Students, easily here our first question is done. Now students, in question number second, which is also exam oriented IMP numericals, you tick mark in IMP list. Question is, find the direction cosines of a line which makes an equal angles with the coordinate axis. So very easy. Equal angle means, students, cos alpha, cos beta, cos gamma, same. So students, I will take here direction cosine L, M, N, N, where L and N are equal, means L equal to cos alpha, M equal to cos beta, and N equal to cos gamma. But where cos alpha is equal to cos beta is equal to cos gamma, according to your question given, equal angles are making, and you property known, cos square alpha plus cos square beta plus cos square gamma is equal to 1, and that I apply in the way of finding the values. So I just apply cos square alpha, cos square beta, and cos square gamma is equal to 1. But cos square alpha, cos square beta, cos square gamma indirectly are same. So can I write here same as cos square alpha, and cos square alpha? 3 times cos square alpha. It means cos square alpha is equal to, students, 1 by 3. So cos alpha, which is 1 by root 3. And that your answer, students, direction cosine ready. Direction cosine our ready for cos alpha, cos beta, cos gamma, which is 1 by root 3, 1 by root 3 and 1 by root 3 is very easy. Students, this answer is correct, but you also taking here plus or minus, then also correct, because direction cosines in the both way running, because here square root taking. Now question number 3. If a direction angles are given, and find out direction cosine. If direction ratios for a line given minus 18, 12 and minus 4, find its direction cosine. Very easy. Ratios given L, M, N, minus 18, 12 and minus 4. So very easy. So your direction ratios are L ratio, M ratio, N. We will take minus 18, 12 and minus 4. So students, here L, M, N I just derived in the way of individual separations. Minus 18k, 12k and minus 4k, and sum of squares is 1. You know that according to our properties. And then after easily we derive value of k. So apply on it L square plus M square plus N square, and that will be minus 18k, M become 12k and N is a minus 4k, and do it the expansion. 18 square, yes, 324, 12, 144 and 4 is a 16, and it will be just added. So 3 to 4 plus 144 and 16, here 6 and 4 10 and 4 14, 1 carry, 4 5 6 7 and 8, 4 8 4, yes, it is a yes value for 484 square root. We will write down 22, plus or minus also possible. either only write down plus. So your direction cosine is ready that in the way of LMN, I value known that minus 18k, 12k and minus 4k. So apply minus 18 by 22, 12 by 22 and minus 4 by 22. So my answer 9 2s are 11 2s are, 6 2s are 11 2s are and 2 2s are 11 1s are. So that's your students 11 2s are, your answer is done, and that question is also students easily done here. Now continue in the way of next question. Question number 4. Prove that given vertices are the collinear. In the collinear wise students given questions to prove A 2 3 4, second B minus 1 minus 2 1 and the C 5 8 7 are collinear. And students, you know that collinear definitions, directions either in the same directions, either in opposite. Yes, one more time check. 2 3 4, minus 1 minus 2 1 and last 5 8 7. So I just take that first of all directions. First direction AB directions. It means B position vector minus A positions, minus 1 minus 2 1 minus A 2 3 4, and derive simple way your directions of AB. And secondly I derive to BC. So my first value minus 1 minus 2 minus 3, minus 2 minus 3 minus 5 and 1 minus 4 minus 3. Secondly direction of BC. So C positions minus B positions. C I have 5 8 7 and B minus 1 minus 2 1. Same derive. It is definitely direction are same either in opposite. So 5 and 6, 8 plus 2 10 and 7 minus 1 6. Just you take minus 2 common outside. Same as it is exactly to AB directions. So students, BC is equal to minus 2 times AB, and check here directions are in the minus, so opposite directions. Therefore BC and AB have in opposite direction. Therefore ABC are collinear, and you will check simple way here collinear is done. Now students, continue in the fifth way. Fifth is the IMP and big numericals. Find the direction cosines. Question is 5. Find direction cosine of the sides of given triangle ABC having A vertex is given, B given and the C. Yes, direction cosines for related sides. A I have 3 5 minus 4 minus 1 1 2 and minus 5 minus 5 minus 2. Again I check 3 5 minus 4 minus 1 1 2 and minus 5 minus 2. So very easy. First of all you decide direction of its sides, and students, that's your triangle. Your triangle property known. A to B directions that way first, second B to C directions, and third C to A directions, and the all directions sum is known that 0. Here I first take direction of AB. AB directions, B positions minus A positions. Minus A 3 5 minus 4, and you will check values minus 4 here, minus 4 and 2 plus 4, it is 6. I students 2 common take, minus 2 3, and you will check magnitude. 2 outside, minus 2 3. So my answer is 4 4 9. So finally you done. Yes, 4 and 4 8, 8 and 9 17. So direction cosine of AB direction sides. The very easy. This answer I just write down 2 times minus 2 3 upon the 2 root 17. That cancel. So your answer is minus 2 by root 17, minus 2 by root 17 and 3 by root 17. If you check sum of squares, definitely it is 1. Now secondly going directions BC. Similar, I going ahead. Second points, direction of BC. So B to C side going, that side. Then after C to A. So position vector of C minus position vector of B. And C I have students minus 5, minus 5, minus 2. And minus B is also known. Minus 1, 1 and 2. And my answer is C minus B. Minus 5, minus 5, minus 2, minus 1, 1 and 2. So here minus 4, minus 5, minus 1, minus 6. And minus 2, minus 2, minus 4, 2 common. And take down to modulus 2, modulus. And answer, it is 4, 9, 4. Again 8 and 9 17. So 2 root 17. So my answer is direction cosine of this sides BC. So your answer minus 4, minus 6 and minus 4 divided by 2 root 17. 2 root 17. So your answer is minus 2 by root 17, minus 3 by root 17 and minus 2 by root 17. Now third I will start to C to A. Yes. So continue. Now direction of C to A sides. It means students A positions minus C positions. A known you. How much A? 3, 5, minus 4. And C also students here known minus 5, minus 5 and minus 2. Similarly written in C to A minus C. Yes, A known that 3, 5, minus 4, minus 5, minus 5, minus 2. My answer is 8, 5 and 5, 10, minus 4 plus 2, it is minus 6. Sorry, minus 4 plus 2, it is minus 2. And take it common, 2 common, so 4, 5, minus 1. Yes, and now I going to, yes, its magnitude. And easily we will cover all your answer to direction sides. So its modulus of CA, it will cover 2. You have 4, 5, minus 1. So my answer is 16, 25 and 1. So it total getting 25 and 1, 26. 26 and the 16. Yes, 12, 1, 42, root 42. And that's your simple way answer, students. And now finally direction cosine. Just to derive that 8, 10, minus 2 and each term divided by 2 root 42. 2 root 42 and 2 root 42. Here students your answer is done. 4 by root 42 and next 5 by root 42 and last of the students minus 1 by root 42, and that's your answer. So now students, after ending this 5th questions, I will stop this video and further explanation students I explain you in the next part. Bye bye.